As part of an ongoing study of groundwater at the Kenosha Dunes, my classmates and I were required to identify the gradient of groundwater flow. In order to do this, we needed to identify the elevation of the water table at various points. Since we lacked sophisticated surveying equipment, we devised a plan to measure relative elevations using the equipment we had on hand. Our plan called for us to measure the differences in elevation of 3 points: 2 monitoring wells called PZ1 and PZ2, and the seepage face, where groundwater flows out of the dunes and into Lake Michigan. As far as equipment goes, we attached a laser pointer to a level with duct tape. This would allow us to shoot a perfectly level laser. The laser pointer was to sit on top of a tripod, modified to provide a flat surface. We also had a large wooden board. First, we had to find a place to set up the laser so that it had line of sight to both wells.
So we now have line of sight to PZ1 and line of sight to PZ2.
Next, we set up the board on top of the cover of well PZ1.
Level on here.
After assuring that the laser was completely level, we fired the laser at the wooden board and marked where the laser hit.
Mark it!
The length on the board from where the laser hit to the bottom of the board was measured to be 3.26 feet. We then moved the board to PZ2 while keeping the tripod in place and repeated the process. This measurement was 3.57 feet. These measurements only gave us the length from the point of the laser to each well cover, but when we measure water levels, we do so from the top of the well casing.
Well, that's a lot better.
So we needed to measure the length from the well cover to the top of the casing for both wells and then add it to the overall length measurement. This yielded measurements of 3.58 feet for PZ1 and 3.73 feet for PZ2. Finding the difference was then just a matter of subtracting. This whole process was repeated, and the average difference between PZ1 and PZ2 came out to be 0.14 feet. Next, we moved the tripod and laser as close as we could to the small cliff created by erosion of the dunes. This location was just above the seepage face. We set up the board at PZ1, again on top of the well cover. We fired the laser and measured.
Mark it!
After adding the length from the well cover to the top of the casing, we obtained a measurement of 3.93 feet. Next, the tricky part. In order to get a good vertical measurement to the seepage face, we placed the board under the tripod, ensured it was level, and extended it over the cliff. We then measured from the seepage face up to the board, and after, from the board to the laser. These two measurements added together gave us 11.54 feet from the seepage face to the laser. We subtracted our previous measurement of 3.93 feet from the 11.54 feet to get a difference of 7.61 feet between the seepage face and the top of the casing at PZ1. By setting the seepage face elevation as 0 feet, we had our relative elevation of PZ1, 7.61 feet. To get the relative elevation of PZ2, we simply had to subtract the 0.14 feet difference that we identified earlier, which gave us an elevation of 7.47 feet.